So what's up guys, today we are going to be deploying a very simple project on AWS, rather should I say on Kubernetes rather, yeah. And for this project, it's just a dummy project. My manager reached out to me that I need to deploy a fruit app, let's say an application that our developers just built, and I need to deploy it on our EKS cluster immediately. So this is a very prioritized task. You can see it's a high priority task. Please confirm once the deployment is done. So this app, let's look at it from this way. The image has already been given to us, but I won't use this image. I'm going to build a new image from scratch. But to tell you guys a little bit about the application, it's just a simple shopping application just for fruits. So this application had been worked on, not really built, but have been worked on by a colleague of mine, Peter, and he's a DevOps engineer also. So to just explain a little bit about the application, it's a monolithic application that has a database running PostgreSQL. It was actually using SQLite, but because of Kubernetes, we needed to split it up a little bit, so we implemented change the database engine to PostgreSQL. So to take a look at the settings.py, as every dynamic website has, there's always a .env or an environment variable to connect to other sources. For example, let's say some microservices, front-end, back-end, like 3-tier applications, they need some environment variables. Front-end to communicate with back-end, back-end to communicate with database, so on and so forth. But for this application, it was hard-coded into the settings.py, and I believe that's not a good practice. It's not, but because of the simple nature of the project, we'll just leave it the same way. So if you can see now that the database engine was changed from SQLite to PostgreSQL with these details hard coded. So you can see now the name, the username, the database name, the password, and then the host. The reason why I emphasize on the host is because we are going to deploy a PostgreSQL instance in Kubernetes. Very simple, very short. There are different ways we can do that. We can actually use status sets, we can use deployments, but personally I don't like deploying databases in Kubernetes. The management overhead is too much unless I don't have a choice due to the policies of the organizations, etc. But normally deploying your databases outside Kubernetes is the best practice, just to be honest. So but for this now, the database host is going to be called DB. So we need to deploy, we need to create a simple deployment, and after doing the deployment for Postgres, we are going to create a service for Postgres with the name DB, because for us to access that Postgres pod, there needs to be a service, a Kubernetes service that routes traffic into that particular pod. So to do this, let's just get right into it. Let's get straight into this particular project. But let's take a look at the Docker file. Then we can continue. So the Docker file here is simple. The base image is Python 3.10 Slim, which is smaller than the normal Python 3, and I believe it's actually very good. You can try using Alpine, but there are some applications that the requirement.txt file are not detailed because of some oversight from developers or something else in the code, which is still an oversight. So Python 3.10 Slim is actually a very good image. The work directory here means that these files here are going to be stored in the /app. That's where our application are going to, just the working directory. This command installs some dependencies that are not captured in the requirement.txt, or there are some libraries and etc that we need to install that these requirements need to work on, and then to copy this. So the major part I'm going to explain here now is about the port exposing. This application runs on port 8000. So I'm going to expose this application on port 8000, and then we're going to create a service that routes to container port 8000. So it's a very simple project. And then the entry point.sh, which is like the main command of the applications, the series of command. So The entity.sh here just holds some commands here, which is the migrate command to run database migrations on startup, and then the major command we have here, which is to start the server on port 8000. So I believe you guys have a little bit understanding of how the application works. It's a monolithic application, as I said, but we are going to decouple a little bit, like taking out the database and in Kubernetes. So based on the requirements of our boss, he said he wants it to be deployed in the fruit namespace. I already have the YAML file, everything has been written down. I'm just going to go over it a little bit, and then I'm going to build the image, push it to Docker Hub, and then deploy it immediately. So let's get right into it. So as you can see, I have the file here, and then I already have the deployment here also, app.yaml, db.yaml. So if I cut db.yaml, you see that I have this deployment here with one replica. As I said, this is just a simple project. Postgres can be deployed as a state. We said that's the best practice in Kubernetes. And another best practice is don't even deploy databases in Kubernetes. Don't. Although unless some policy constraint from your organization, that's all. So as you can see here, the container port of Postgres as usual is 5432, unless you want to customize it. And then something else here is about the environment variables. The Postgres password is Peter, the name, the username is Postgres, the database is Postgres, and then this is where our files are mounting the volume. So this is just to persist our files, but in real sense these files are not really persisted. Data is not persisted because it's an empty directory. When the pod dies, everything dies with it. So it's not really a good practice. We can actually use the real persistent volume on Kubernetes. So, but since it's a very basic project, obviously we don't need that. But here comes one of the most interesting facts now, DB. So the Kubernetes service we are going to be creating, the service stands as a proxy, right? Request from your application hits this service, which is called DB, and service names are used similar to Docker. Container names, you can communicate with containers using container names, right? But in Kubernetes, you can't communicate with other pods in a different deployment, etc., with pod names. No, you communicate with them using their service names. So this is a service here now, and then your request goes into this service, and then the service routes it to the pod you want. So for now, our database, our service name here is called DB. And then we just take a little let's check the application host. So let's see, not host, rather application YAML file. So here of course we have the namespace to be created called fruit. Then we also have the deployment called fruit in the fruit namespace above here. So these are three resources in one YAML file, which is somewhat like a good practice. And then you have one single replica. So I said this is just a test, it should be more than one. That's the main purpose of Kubernetes. And then majorly container port 8000. If you want me to explain these concepts, I can actually pick out the deployment and make a full video on how this guy works in detail. So you can drop that in the comments below for me to just make that video for you guys, and I'll gladly do that. And then the service now, if you take a look at these specifications here, spec, you can see this is type load balancer, which means it's wide open to the internet, anybody can access it. But if you take a look at this guy up here for Postgres, you can see that it's a cluster IP, meaning only applications inside that particular Kubernetes cluster, that namespace, can only access this guy, unless they use a fully qualified domain name to access it from other namespaces. But this guy is private. In essence, this guy is private, and then this guy is public. So you can see this image here now. I don't want to use this image. I already have my image, but I will still want to build this image locally for you guys to see, and then I push it to Docker Hub, and then I use it here again, so everything goes out fine. So let me just get that done. Let's see, cd into my project, say docker build flag t. I like giving my image name, just tagging it directly with giving it directly without tagging it, that wastes some time. Ojabo John dash fruit dash app slash fruit dash app, and then give it dot, because this is where the Docker file is currently. So this guy should work. I already built it, so it should even use some caches just to speed things up. I already built this guy a few minutes ago, so yeah, so it's using the cache. Yeah, using cache and everything. So it's really built. I'm still going to push this guy to Docker Hub. So if I say docker push, so everything here was mounted, and to show that this guy has already been built. So no problem, everything works fine. Now it's just to edit that image name by viming into our application.yaml file. So here we'll change the image, and then I'll paste my guy here, save it, and then I'll just start creating. But note, whenever you are deploying applications to just deploying applications in general, you start with the prioritized ones. You can't deploy the backend first before the database. The database is the most important because the backend needs the database to function. So that should be database, then deploy the backend, then deploy the front end. So we're going to start deploying with the database here now, and then we'll manually create the namespace. So I can just say k create ns fruit namespace created simply. And Kubens is just a tool for me to use to stay on my namespace, to set my namespace session, so I don't have to be running kubectl get port flag n, then the namespace name. All those things waste a lot of time, and you can actually save over 30 hours a year as a DevOps engineer by using these little tips. So I can say Kubens fruit. So you can now see that the context has been modified, and I am in the namespace fruit. So if I say kubectl get pods, I actually minimize this command to pods using aliases, or aliases, so you pronounce it differently. So you can actually use this guy to your favor also. So there are no pods here, but if I say k apply flag f db.yaml, you can see database was just created, and if I say pods, you can see that this guy is running. So the next thing is going to be to apply my application file, and I was expecting this error, not really an error, a warning, and it's just that I created the namespace manually and it was also specified in the file to be created. That's why it threw this error. So if I say pods container creating, it's now running. So if I say kget svc, I can now see this guy, copy the external IP address, and then let's go to the browser to check it out if it's actually working as expected. Let's see, it's taking some time. Okay, this is HTTP. It should be HTTP, not HTTPS. So you can see that the application is up and it's running. So it is just a very simple application that I believe junior DevOps engineers should just play with, deploy, and then just get your hands dirty around it with Kubernetes. So I said this is just a speed run through this guy. If you want me to slow down to break down all these concepts, I gladly will. Just let me know in the comments below, and I'm always here to help you guys. So thank you very much for watching, and please don't forget to subscribe to the YouTube channel. It helps us to grow and also encourages us to make more quality content for you guys. So yeah, before I go, simply clear out your resources. Simple command K, delete, flag F, application.yaml. That's all. So this should clear everything up. Deleting the namespace. The namespace actually holds every other thing, so the database and all those stuff, they are wiped out. You can actually set finalizers to minimize errors like this, so in case someone deletes your namespace, it does not get deleted. So that's it for today's video. Bye guys, and see you in the next video.